All right, here we're going to look at the difference between theoretical and experimental probability and get more practice in calculating those things. Now, first of all, what's the difference between theoretical and experimental? Well, the theoretical probability is the type that we've been finding, and that assumes that everything has an equal chance of happening. Experimental probability, on the other hand, actually records what happens. So taking a coin and flipping it a number of times and recording how many times it comes up heads and tails is an experimental probability, whereas assuming that the coin is going to land on heads half of the time and tails half of the time, that's a theoretical probability. So the homework's going to be on page 479, and in problem 5 it says the spinner is spun 20 times and the results are recorded in the table. First of all, taking a look at this table, it shows that a 1 showed up with these marks. And now what do these marks mean? That means that every time it showed up, whoever was recording just put a little tally mark for each time that the 1 showed up. Since there are 4 marks here, that means that a 1 showed up 4 times. When we're tallying things, if we have 4 marks and we get to our 5th one, we put this diagonal line through it to signify a group of 5. That means this 2 showed up 5 times. Same thing happened with this 3. This is a group of 5, so 3 showed up 5 times. When it came to the 4s, there's a group of 5 plus this extra 1. That means there was 6 times that a 4 showed up. First of all, let's find the probability of getting a 4. Remember that probability is the number of successful outcomes over the number of possible outcomes. And when we run this experimental probability, the probability of getting a 4 is, well, how many times did a 4 show up? A 4 showed up 6 times out of the total 20 spins. So we go ahead and divide this out and grab your calculator. 6 divided by 20 is 0.3, which means 30% probability. So if we want to find the probability of getting a 3, we look to see how many times did a 3 show up, and that was 5 times. So the probability of a 3 is 5 out of the total 20 times. And 5 divided by 20 is 0.25, which is 25%. All right, 50 people were surveyed leaving the zoo, and they were asked what their favorite exhibit was. The results are in the table. Now, if a group of 425 came through, how many would say their favorite exhibit was the planetarium? Well, the first thing we want to find is the probability of getting the planetarium. Right? Looking at the table, the planetarium showed up 8 times. So that's 8 out of the total of 50 people. When we divide that, we get 0.16, which is 16%. Now, if I want to know about this other group of 425 people coming through, that means that it's likely that 16% of those people are going to say that their favorite thing was a planetarium. So to find that, we're going to take 16%, the 0.16, times 425. Do that on your calculator, and you get 68 people. So now if 600 came through, how many would say their favorite was the aquarium? Again, find the probability of the aquarium. So there were 9 people out of the 50 that said aquarium. You can divide that on your calculator and get 0.18, which is 18%. That means that 18%, 0.18, of the 600 people coming through would say aquarium. You can calculate that, and you'll find out the answer to be 108 people. A bunch of people were asked how they like to pay their bills, and the results are recorded in this table. First of all, what's the probability that someone would say they preferred to pay their bills online? Well, it's easy to find how many people said online. So that probability will have 45 in the numerator. But we need to know what the denominator is. In order to do that, we have to find out what the total, how many people were surveyed. So go through and add up all of the frequencies. When you do that, you should get 200. That means we're going to have to take 45 and divide it by 200. That'll leave a decimal of 0.225, which is 22.5%. If a new store is expecting 3,500 customers, how many would they expect to pay by check? So first, find the probability of somebody saying check, and that'd be 52 out of the 200. We get that from right here. That ends up being 0.26, which is 26%. So 26% of those 3,500 people should be saying that they would prefer with a check. And that would be 910 people. In an assembly line, 56 out of 60 parts have no faults. How many parts would have no faults out of a batch of 12,000? So first, identify the probability of having no faults. That would be 56 out of 60. If you calculate that, you'll get 0.93 with the 3 repeating. Now, how many parts would have no faults out of a batch of 12,000? Take that 0.93333 repeating and multiply it by 12,000. When you do that, you should have 11,200 parts. I want you to do these 2 problems on their own, and then there's one more slide with some more problems that I want you to do on your own. So pause the video, do these 2. Then when you're finished, go on to the next one.